Hello everyone, this is Naidu from Techno Legal Forum. Welcome back. In last class, we have studied very briefly, touched upon Kerberos, security, assertion, markup language, radius, then OAuth and OIDC. Today we will discuss each one of them a little more in depth. Okay, let's start with Kerberos. Okay, so Kerberos, the word, as I mentioned last time, seems very peculiar. In order to remember this word, I searched the net. It found that very interesting. In Greek mythology, Kerberos means three-headed dog guarding the gates of the underworld. Okay, just for this, Kerberos is developed by MIT, the topmost institute, research institute. So we also know that Kerberos is a authentication protocol. Authentication means validating the identity of the user system is nothing but authentication protocol. Authorization is provided at the application level. Application will provide the authorization, but the core function of a Kerberos protocol is authentication. It uses very strong cryptography, that is a mathematical calculations, and encryption, because encryption is the, as I mentioned, is very key. I have given in-depth video about that. I will share that video if you notify me that if you don't have the access or you have not seen that. So it allows the clients, servers, when I say clients, that includes users, to prove their identities to each other over untrusted network without ever, this is the key thing, without ever sending passwords across the wire. So that is why it is secure enough, right? Where exactly the Kerberos is in use? It is used as a authentication backbone for our Microsoft Active Directory and even Linux platforms. So basically the core idea here is it authenticates the user, means it recognizes the user by verifying the user credentials in the database such as Active Directory, and once it is verified, it issue a special pass we also call in terms of ticket. Okay, we'll see that. To access multiple services, Windows services, see, accessing even the folders, shared folder, it needs authentication. That all happens transparently because of this Kerberos. Kerberos is kind of a de facto thing which happens within the network work, when the user logs in. That's why we can just categorize as internal. This works internally. And again I am stressing, Kerberos contains KDC. We will come to that. What is key distribution center? It has two components. Okay, that also we'll see. This entire Kerberos is running on domain controller. In Windows environment, you know what is domain controller. It's more of a authentication server, right? So everything is inside this domain controller. That's why that authentication which we are going to discuss, it's the part of this whole architecture. Okay, let's move on. Okay, this will give much more idea about the working of Kerberos. So as I mentioned, key distribution center is nothing but a central trusted authority. Contains two important blocks or components: authentication server AS and ticket granting servers TGS. This leave on, they are on domain controller. So how exactly it things happens? Let's see. There are multiple steps. I have now mentioned the overview or summary of the main core principles of the working of the Kerberos authentication protocol. Okay. So first, step 1. Here we have a client. What client means? User. It sends its identity request, means it want to authenticate its identity. It's nothing but client sends a request containing only the username and a timestamp encrypted with password as. Please focus on these three elements: username, timestamp, encrypted with user password. Here we are talking about symmetric encryption. In that last video I explained. Okay, why this it does, why it is using the timestamp. See, there we said random number generation. Yes, we can do that, but why can't we use the timestamp? Because timestamp is at a specific instant. What is the time? Next instant it changes. It's nothing but random in nature. That's why it does, we'll come to that. So this user sends the username and the timestamp. The timestamps, what it does, it encrypts with user password hash. Remember, through hashing technology, which we already have a dedicated video for that, through hashing you convert the password, transform the password into an hash. In other words, password is represented by hash. Hash is a one-way operation. If anybody captures hash, they cannot generate the password. That is the uniqueness of the hashing algorithm. This hash is used. Okay, this hash is used as a primary, symmetric key. Remember, in encryption, we need, for encrypting something, we use a key. That hash is used as a key to encrypt the timestamp. See here, user password hash. The password timestamp encrypted with user password hash. After creating the password hash, use that password hash and encrypt the timestamp and send it to the KDC, specifically authentication server. This authentication server is nothing but our Active Directory, correct? Active Directory contains user credentials. So just pay attention for another moment. What I said last is password hash is used for encrypting timestamp. In order to decrypt, what we need in symmetric key encryption, we need the password hash, right? Now this, where is that password hash available? Remember, this is an authentication server, or you can say Active Directory. Active Directory contains password hash. Much before, password hash of the user. locally this user has a password hash. So he has used the password hash to encrypt the timestamp, and along with the timestamp and username he has sent it. Now in order to prove this is the client which is communicating to the KDC or authentication server, what is the best way? You need the password hash. So what it does, since it's already having a password hash, that password hash, the authentication server or domain controller or Active Directory password hash is already there in the server, in the KDC. The password hash which is used to encrypt, I'll say password PH, is used and encrypted the timestamp by the client and sent to the server. Server ahead of time, it is already storing the password hash. Encryption opposite operation in order to decrypt the timestamp. Timestamp is sent. Timestamp is some kind of envelope now. It has been converted into a kind of unreadable characters. Timestamp. You cannot read that. In order to read the timestamp, you need a decryption key. What is a decryption key in asymmetric encryption? Is nothing but password hash. Password hash anyway existing here. If it is able to decrypt, because it's having a password, it is able to decrypt. If it decrypts, then what it means? The key, that is password hash, is exactly the password hash which is used to encrypt the timestamp by the client. So it means that the client is the genuine one and the server is 100% sure that is the client it is supposed, it is intended to communicate, because NT hash is there. That NT hash is verified using the server side password hash. Instead of NT hash I should say password hash. Therefore this client is authenticated. Okay. Once authenticated, so this arrow mark is this side. This AS will issue ticket granting ticket. Remember this keyword. It's always bit confusing always. Ticket granting ticket. It exactly means what authentication is done once for all. Right? All this process happened. That is why you got authentication server with part of the KDC has issued you TGT. It means this client is genuine one, it is authenticated, right? So TGT will authenticate, it stay in the memory of the client for 10 hours I believe. So this TGT, what is its usefulness, will come to know, will come in next few seconds. Okay. It takes the TGT and issues a service request. What is service? See, these are services, Windows services. Like one example, I will say shared folder. Share folder, if a user has to access, he has to be authenticated. This all happens at the end. So, in order to access this service, it will present TGT with a specific, there are a lot of services here, right? It issues a specific service request to the TGS. Remember, don't get confused. TGT is a authentication part. Okay. Using that plus service request. What service it requires? Suppose it requires Windows, the share folder. You need to browse the share folder. That service request it issues to the TGS, ticket granting server. This will issue step 4. Service ticket is issued. See, these are all this is this side. Client will get service ticket. Using this service ticket, it will access the service. Okay, access granted. Remember here, KDC looks up the user password hash. Remember, if it is able to decrypt, then the request which is coming is authentic, because both are saving same password, right? So the same hash of the password. If it is able to decrypt the time, so it is indirectly means that the client is authentic. See, authentication server will issue TGT. Remember, I told TGT. Ticket granting server. This is a ticket granting server, which is a part of the issues this specific service, not all the services, specific service, in exchange of a valid TGT. So it supplies TGT plus service request. This will give you service ticket. We can represent by ST. Using service ticket, ST is presented to the service. Service recognizes and access is granted. It sounds very complicated, but very interesting. Okay, so application service, the target resource like file server, database, email, all this is granted. So all this happens transparently. You will not be finding anything explicitly you have to provide. These are all happening because of the key distribution center, because of the Active Directory, because of the ticket. So the main core point is here, it is a backbone of single sign-on, which we are going to see later in Saml. We'll see in Saml the same concept. Single sign-on. See, remember, once the TGT is granted, that identity of the client is established. Once it's established, it stays in the memory. Every time TGT plus specific service what it requires, it combines them and sends the request to the ticket granting service. That ticket granting service issue the service ticket. Using that service ticket, it approaches the service, application service, and access the service. This whole thing happens transparently, and this Kerberos is the main authentication protocol for both Windows environment and Unix platforms. So that is very key thing that we should remember. Okay. Okay. Now Saml, security assertion markup language. Very quickly, I will. We already covered a little in depth in the previous, but this is a diagram which I have not shown. Let me. So user is sitting here, right? Let's say he opens a browser and access one of the applications which is part of the organization. This is one organization. There are dozens of web applications. He opens the browser, he selects one of the application, the application throws up the login page, login, username and password. The moment it does, that application will say, I don't know who you are. Okay, because without identity, applications cannot give access to its application. The application, so what happens? Access request is done by the user, but since this person is unknown to the service provider is nothing but your applications. Okay. Authentication request is sent through the browser, that is not a security assertion markup language. Where it will be sent? Identity provider. Identity provider is a general term. That see, identity provider is something like your Active Directory or Azure or any database which contains directory services. Directory service contains user credentials. Okay, let me quickly show that. See, directory service user identities, to which group the user belongs, attributes across entire organization. It is arranged in this fashion, hierarchical, so that you can identify the user. To retrieve the information what is stored in the database, that is this protocol is used. Database is nothing but your Active Directory. Okay, LDAP is used to query. You can see here query and also update changes. So Active Directory is nothing but directory server implementation. Okay, so I just brought you here to understand, get an idea of how the credentials are stored, what group membership and what rights they have. All these things will be there, permissions, everything. Okay, so he tried to access in the browser, provides user and login, but the service provider, that is hosting the applications, that specific application, since it doesn't know, it will send. It will means browser will redirect the request to the identity provider, that is nothing but your Active Directory. Active Directory page will come. I mean, authentication window opens. The user provides the details. If his information is there in Active Directory, obviously he will be able to log in. Once he is able to log in, Saml response means from the browser itself, the browser which requested, his credentials and what level of access he has, both the things, authentication, authorization levels, both are sent in XML format in the browser. It's sent back. That is nothing but sending back that access, assuming he's having access to the credentials are there, is called assertion. I'm asserting myself. I'm already there in IDP. You don't have to worry. So that sort of thing. So it is validated. Then only he is able to log into that specific application, one of the many application, one application, let's say one application. Okay, so access is granted, then he is able to access that application. User logs into that application. That is what it means. So here one of the important things is that if suppose one service provider is having one application, multiple service providers are there, let's say SP2, SP3, SP, like that. Let's say I'm giving an example. All these multiple service providers can just use one IDP. In other words, user can log into multiple applications once he gets authenticated, only one time authenticated. That is why it is called single sign-on within the organization. Web-based applications, right? So that is the plus point. And also I spoke about the downside of it, downside and usefulness of it, right? Password fatigue can be eliminated by using single sign-on, and I explained about password fatigue means what, and disadvantage or a little downside, we can say single sign-on. So one if you're able to breach that, the hacker, the one because one time he's logging, if he's able to breach those credentials, he also has the access to multi, but that is offset by using multi-factor authentications and other mechanisms where that is not a possibility, very rare. So basically this is the most common kind of approach is used for accessing dozens of applications in an enterprise organization without giving multiple times username or passwords. So one time authenticated by the IDP, using that assertion, rest of the application within that organization can be accessed by way of Saml authentication. Okay, so that is all about Saml. Let's move on. Okay, Saml is over. OAuth 2.0. This is also very commonly found in our enterprise. OAuth 2.0, that is basically authorization protocol, commonly found. If you read the definitions and its purpose, that itself makes our understanding very easy. It's an authorization protocol, so it is always used in conjunction with authentication protocol. This authentication tells who the user is. Authorization is what level of access he has for the application. So that is provided by this one. So here it's a very I think we have to use this. Okay. It is a protocol that allows applications. When we say applications, external, let's say external. See, remember last session I said about fitness app. Fitness app is some kind of external application we can consider, right? To access the resources in another application, it is allowing the fitness app to access the resources on behalf of the user without exposing the user credentials. Simple. Fitness app is one app. Google Calendar belongs to another app. I open the fitness app, log in with Google. The moment I try to access my fitness app, or suppose I want to use the calendar of Google, not the fitness app, immediately it pops up log in with Google, I provide the credentials, right? So this is what happens. I provide the credentials in the Google, not in the fitness app. Okay, so in other words, I am not exposing my credentials to the fitness app. Once I get authorized by the Google, okay, Google contains, this is entire thing, we can say Google, okay, request, authorization request. Google will ask me log in with your Google account. I log in, then it also throws up one window to allow access for the fitness app to access the Google Calendar. I will give the consent. Based on the consent, I will get a authorization code or token. Using that code, I will access that particular component of Google. See, Google contains so many components: Google Drive, Google Sheets, Google Gmail, everything. But the fact that I have just only given my account doesn't mean that the fitness app can access. It can access only based on the API. API is means application programming interface, right? If you want to interact with any other application, that application exposes APIs. APIs means through which only you can access. For example, Google exposes calendar, right? Google Sheets, another API. Google Drive, another API. Now we are concerned about, let's say, Google Calendar. So this API provides access token. The fitness app will access only that Google Calendar, and on top of that, what level of access, whether read the calendar or make an entry, is all depends upon the authorization levels. So this is basically everything about OAuth. And very important other thing is OpenID Connect will provide you on top of OAuth who the user is accessing, kind of identity or authentication. Okay, so whatever explained here, it is like you click on the right. Once when you try to access in the Google this fitness app, you always get login with Facebook, login with Google account. Is nothing but authorization request, right? Then also, since you are accessing Google, it will ask, okay, are you allowing for the fitness app to access your calendar? Yes or no? You will say yes. Then Google issues authorization code. Somewhere I saw here authorization code. The direction seems different here. Then there is exchange app. Fitness app exchanges its code for access token. And API. See, API when I say particular component of the external application. That application, in this case, Google Calendar. So whatever level of access it is defined, based on that it gets the access. Okay, so this is something most commonly you will find in enterprise network. Accessing external applications also in Saml within the organization. In Kerberos, internal basically authentication of the workstation with the user credentials using the Active Directory. Okay, so hope that makes clear. Okay, so this is one of the last important protocol, remote authentication dial-up services. Okay, don't worry about this terminology. Let's say user or a device. See, you are outside your organization, right? Suppose you are outside the organization, you use the laptop, you are the user here, requesting access to the corporate network. Your request will go network access server. It's a general word. It is nothing but your Wi-Fi access point. Even when you are inside organization, you have Wi-Fi access points, right? The credentials will go like that. Or if you are connecting from home, VPN gateway, or it can be switch firewall. So these are all network access server we call. Okay. This is just a forwarder. It doesn't do anything of intelligent thing. It takes the credentials, it sends via UDP port. Why not TCP, you will ask? Yeah, that doubt will come, right? UDP is a connectionless, what you call no acknowledgement of the packets received, right? Whereas TCP has acknowledgement. Delivery is guaranteed. Why not TCP? Why you are using this? Simple reason is, one of the reasons which I read somewhere is, it's a matter of speed versus reliability. When the speed is very important compared to reliability. Reliability means acknowledge, you send packet, you receive packet. These are all kind of a handshake, right? When speed is important. Why? When will be the speed of important? When thousands of users are connecting, multiple devices, multiple users. Every second you have so much login requests coming, thousands at one go. If you use TCP, it will slow down. Okay. Therefore, UDP is used to accommodate successful logins, right? So that is why UDP is a faster protocol. That's why it is used. Okay. Now, the radius server. This is the main thing. This job is, we can say, client of radius server. It's a subservient client of radius server. This radius server is what contains all these three: authentication, authorization, accounting. Okay, so here Wi-Fi client, VPN client, all these things, credentials are sent. This will send these details. The moment we say authentication, AD comes into picture, querying the database, directory service by lightweight directory access protocol, LDAP, local database. These are all part of this one, including authorization. This will check everything for each of the login requests. Based on its validation, it will accept or reject. If it is accepting, then the NAS is more of an enforcer. Enforces the access decisions of the radius server. That's why it's enforces access decision. And once it does it, then only it allow the access to the protected resources. Okay, that is how this entire radius works. So we can say remote radius will be coming into picture automatically when a user in this method is connecting to a network external. This is external. Internal is Kerberos. Even Saml we can say internal, but it's more related to accessing multiple applications, web application developed by the organization using single sign-on. Okay, so now let's move. Okay, we have reached end. So that's all we have. We have covered all the important protocols, and there all these protocols are found at a time in a multiple organization. They are appearing and doing their activities depending upon the situations what we have discussed. Okay, whether it's internal user connecting or whether user getting authenticated, when a system within the organization user logs in with his credential, then KDC comes into picture, right? And if user is connecting from outside using the Wi-Fi, right, and then radius comes into picture. User is accessing a web applications, dozens of applications which are developed by the organization or procured by the organization for various functions that it has to deliver. When he logins to the browser will redirect to the IDP. IDP will give the assertion, means this user is available, you can allow him. Using that he will access, that is SAML. Then in OAuth it can go beyond external to the network and access the third party application on behalf of the user through using API, very limited authorization. And OIDC is built on the top of the OAuth, and it will give the authentication who the user is. Okay, so this sums up the overall protocols what we studied. In coming sessions we'll take up other important topics of interest. Have a nice day and we'll catch you soon. Bye.